An exclamation point in maths is not called an exclamation point, it's called a factorial. Alright, so that's what we're doing right now, factorials. So this isn't 5 exclamation, this is 5 factorial. And what that means is we take the big number that we're doing the factorial of and multiply it by every number littler than it. So 5 factorial actually means 5 times 4 times 3 times 2 times 1, which comes out as 120. So 5 factorial actually means 120. It's just a different way to write it. 4 factorial, 4 times 3 times 2 times 1. There we go, 24. 2 factorial, nice and easy. 0 factorial isn't 0, okay? 0 factorial is 1. That is a key thing that you need to note, all right? We don't want to get that one confused. Okay, then we want to be able to simplify fractions with factorials. So I could write 8 factorial and 3 factorial as 8 times 7 times 6, 5 times 4 times 3 times 2 times 1, and put him over the same thing, all right? And what we can see here is that the 1's cancel, the 2's cancel, and the 3's cancel, which just leaves me with 8 times 7 times 6 times 5 times 4, which I can then solve. We can also rewrite our fraction as 8 times 7 times 6 times 5 times 4 times 3 factorial. Because we can see this bit I crossed out here is the same as this bit down here, which is 3 factorial. So rather than having to write out those bits in full, we can just leave them as 3 factorial and then cancel, which gets us back to the same point, 8 times 7 times 6 times 5 times 4. Which equals 6720. Cool. All right, so this one's a good example of using the keeping it as a factorial thing, because 90 times, we would have to do all of them way down to 1, which sounds horrid. But we can change that to 90 times 89 factorial to make it match the bottom. Once the bottom matches, we can just cancel it out, and then we've just got 90. Done. So much easier. All right, when you have 2 numbers on the bottom, you want to pick the bigger number. So we're going to turn this into 14 times 13 times 12 times 11 times 10 factorial, okay? Then we're going to rewrite the smaller, so expand out the smaller one, but leave the bigger. So we're going to take 4 times 3 times 2 times 1, and then leave the big one as a factorial. And now it's just a cancellation party, so we want to cancel whatever we can. So the 10 factorials cancel. I know 4 can cancel with 12, which leaves me 3. 3 cancels with 3, so that's now gone. Remember, these are technically 1s, okay? It's not gone, it's not a 0, it's technically a 1. 2 cancels with 14, that leaves 7. And so then on the bottom, all I'm left with is that little 1, which anything divided by 1 is itself, so it doesn't really mean anything. So we're just going to leave it as 7 times 13 times 11, which we can actually calculate. 7 times 13 is 91. Yeah. And then 11 times 91 is, well, what am I doing? That's silly. 1001. Done. These are the questions on factorials I want you to do in the textbook.